August 2008, China hosted the Olympics to great fanfare. But only a few months earlier, China was host to an unwelcome guest, a massive earthquake that devastated the Sichuan Province. As a result of the earthquake of May 8, 2008, nearly 70,000 people died and millions were left homeless. The magnitude of the earthquake at its epicenter was 7.9 on the Richter scale. As the name suggests, the epicenter is where the most damage occurs. As you get farther away from the epicenter, there is less damage. In fact, the amount of damage decreases dramatically. This suggests that the magnitude of an earthquake changes in a nonlinear fashion. This color-coded map from the U.S. Geological Survey shows the intensity of the earthquake near the epicenter. The red areas are where the most intense earthquake activity occurred. The green area showed moderate activity. The distance from the red area to the green area is about 150 kilometers, or about 100 miles. A very short distance compared to the overall size of the earthquake. Because of the dramatic changes in intensity from one point to another, earthquakes are an ideal example of exponential functions. Unlike a linear function, which changes in value in a constant way, exponential functions change value in big leaps. If earthquake intensity could be modeled using a linear function, then the map would show a gradual change from red to green, so that a larger area would be affected by the earthquake. Instead, a nonlinear function, in this case an exponential function, shows the worst of the earthquake damage localized to a relatively small area. Exponential functions and their inverses provide ideal models for us to better understand earthquakes. But before applying these mathematical models, let's first get a better understanding of what an earthquake is.